Today we are going to talk about the guidelines for power system safety and stability. The role and significance of the guidelines for power system safety and stability serves as a guide for the safe and stable operation of the national power grid and electricity systems. It has made detailed and specific provisions on requirements for all aspects of the safety and stability of the power system from 6 aspects: the basic requirements for ensuring the safety and stability of the power system, the safety and stability standards of the power system, the calculation and analysis of the safety and stability of the power system, the management of the safety and stability of the power system, and the relevant terms and definitions. Serious study of this regulation has important guiding significance for ensuring the safe and stable operation of the power system. This guideline provides basic requirements for ensuring the safe and stable operation of the power system, safety and stability standards for the power system, and calculation methods for system safety and stability. Power grid operating enterprises, power grid dispatching agencies, power production enterprises, power supply enterprises, power construction enterprises, and units engaged in power planning, survey, design, and research should all comply with and implement this guideline. This guideline is applicable to the power systems of 220 kV and above, and can be followed for power systems below 220 kV. In the Learning Point 1 of the Guidelines for Power System Security and Stability, the General Principles section points out the purpose and scope of use of the guidelines. To the section on basic requirements for ensuring the safe and stable operation of the power system, we note that a safe and stable operation of the power system should be guaranteed. 3. The safety and stability standards for withstanding large disturbances emphasize the specific requirements of several special situations in the power system. 40. For the part of power system security and stability calculation, proposes the tasks and requirements of security and stability analysis, requirements of static security analysis of power system, the concepts and judgments of power system security and stability, and the concepts and conditions of power system transient stability. It provides the concepts and analysis prerequisites of the dynamic stability of the power system, the concepts, analysis conditions, and analysis methods of power system voltage stability, and makes clear provisions for the concept, purpose, and effectiveness of the reinscription function of the power system. 5. The management part of the safety and stability of the power system points out the necessity of the safety and stability analysis of the power system in the planning, design, and construction of the power system, and makes clear requirements for the safety and stability analysis of the power system dispatching and operation, production technology, and scientific research and experiments. 6. The terminology and attribute section and 1 provides specific concepts for the N1 principle of safety and stability in power system, hub substations, important load users, and inter-SIS interconnection lines. The following is a comparison between the new and old versions of the guidelines for power system safety and stability 2010 since 2010. With the large-scale integration of new energy and the development of ultra-high voltage AC/DC transmission technology, China's power system has further expanded in scale, forming a cross-regional and interconnected pattern. At the same time, new power equipment has been widely integrated, and the characteristics of conventional power source systems have undergone profound changes. In recent years, large power outages caused by ultra-high voltage, AC/DC, and large-scale new energy failures in foreign power grids have occurred from time to time, in 2018. The closure of the ultra-high bellow multi-voltage direct current in Brazil led to a 321 massive power outage, and Brazil's power grid was almost completely shut down. In 2019, during the A19 accident in the United Kingdom, the power grid was struck by lightning due to insufficient grid interconnection performance at both coal-fired power plants and distributed offshore wind farms. The system frequency was dropped significantly, which in turn activated the low-frequency load-shedding mechanism, resulting in the automatic disconnection of a substantial amount of electrical load. In the face of the significant challenges and potential risks posed by new technologies and new situations to the power system, the safety and stability standards for the electricity grid had been upgraded from industry standards to national standards, which is completed by the National Technical Committee for Standardization of Grid Operation and Control, entrusted by the National Energy Administration to meet the practical needs of China's developing power system. The main content of this standard consists of 4 parts. 1. Basic requirements to ensure the safe and stable operation of the power system. 2. Power system safety and stability standards. 3. Calculation and analysis of power system safety and stability. For manage safe and stable working power system, the standard applies to backbone power systems with voltage levels of 220 kV kV and above, while power systems below 220 kV can adopt these standards as a reference. The basic requirements to ensure the safe and stable operation of the power system have 7 major contents, of which general requirements and here are changes as follows compared with the old version of the guidelines. 1. Section 3.12 of the standard made clear requirements for power generation structure, and the new FG2 articles related to DC power supply have been added. F includes the mutual adaptation and coordinated development of AC and DC, as well as the type, scale, and reasonable layout of power supply installation, with a certain degree of flexible adjustment ability. To the new section 3.17 clarifies the matching requirements for secondary equipment and primary equipment in the power system. 3. The new section 3.18 states that the short circuit ratio of DC transmission, new energy and other power and electronic grid connected power sources shall meet the requirements. There are 5 grid structures: the construction of receiver systems, power source connection, compliance with the grid access, hierarchical and regional segmentation, and interconnection between power systems. Compared with the old version, the construction part of the receiver system is mainly improved and supplemented for the increase of DC transmission feeders in the receiver grid. 1. The receiver system should have sufficient reactive power compensation capacity, and dynamic reactive power regulation equipment should be reasonably configured in areas concentrated with free fall points and loads. F2. For the DC feed-in receiver system, the DC landing points should be optimized, the near-zone grid should be improved, the support capacity of the system for DC should be improved, and the overall scale of multiple feed in DC 2 times or more should be adapted to the receiver system. Okay, boys and girls, that's all for today's lesson. See you next time.